This is for Calculus BC. This is the integral quiz, part 1. We are given the expression, the integral of x to the third cosine of x dx. So, as you can see, this is integral by parts because x to the third, which will eventually get down to 0 as you take the derivative of it, and cosine of x, which will infinitely go between cosine and sine as you take the integral of it. So because of these two properties, we can take the tabular method as our preferred integration method. So you'll start off with x to the third sine of x, because the integral of cosine of x is sine of x. Then we're going to add 3x squared, because the integral of sine of x is going to be negative cosine of x. We're going to subtract 6x, integral of cosine, which is only sine, will allow this subtraction to occur. Then another subtraction, 3 multiplied times 6 cosine of x. Of course, can't forget our constant. So we are given the expression, the integral from 0 to 2 of 1 over square root of 4 minus x squared. Some people may recognize this as an identity. This is the arcsine, and because of this value, it's going to be over 2, which is the square root of 4. So it's going to be x over 2. We're going to evaluate this from 0 to 2. So arcsine of 0 is 0. Arcsine of 2 over 2, which is the same thing as arcsine of 1, is equal to pi over 2. So we end up with our answer, pi over 2, and so we know that the integral converges. We are given the expression, the integral from 0 to infinity of x e to the negative x dx. So, because of this finite term and this infinite term, and talking in terms of differentiation and integration, we know that this is going to be by parts. So let's start by doing tabular method. So we know the expression will be negative x e to the negative x, because of the integral of e to the negative x minus e to the negative x. Because the derivative of x is 1, the integral of negative e to the negative x is simply positive e to the negative x. But when talking about by parts, you subtract the next term. So let's kind of put this to the side. So now we need to determine we have to interpret this from 0 to infinity. So we're going to have the limit as x approaches infinity of negative x e to the negative x minus e to the negative x minus, well, because whenever you plug in 1 or 0 into the exponent, it turns the value into 0, or the value to 1, but because of this x, this entire e to the negative x becomes 0, while as this other e to the negative x becomes 1. So we're subtracting negative 1. Now we have to evaluate this limit. So basically, we start out with so let us rewrite this first actually. So we're going to say negative x all over e to the x minus 1 over e to the x. So from this we know that this expression will end up being negative infinity over infinity, which is indeterminate. But after doing L'Hopital's rule, we'll end up finding that the limit will go to 0 because it will turn into negative 1 over infinity is equal to 0. At the same rate, this term will go to become 1 over infinity is equal to 0. So our entire expression becomes 0 minus 1. Well, 0 minus negative 1, so then it becomes positive 1. So the entire expression equals 1. So we're given this expression, dp dt is equal to 0.4p minus 0.001 p squared. We are asked to find the carrying capacity for part A. So, first step here, one of the ways to get carrying capacity is to separate this out so we have some constant outside p, outside of 1 minus p over our carrying capacity. So, let's try that. So, the first ways that we can do this is by going and saying, dividing the entire expression, dividing by 0.4p. So by doing this, we end up separating this out to 0.4p outside of 1 minus 0.0025p. So, as you see, this part of our decimal is a quarter. So we know that we can likely separate this out into some fraction. And in fact, by doing 1 divided by this decimal, we end up getting 400. So if we multiply that against, we can turn this entire expression into 1 minus p over 400. And this matches our original expression in a way that the inside shows us our given carrying capacity, 400. So there's your answer. So this is a continuation of problem 9, the integral quiz test, or integral quiz. So we are given this entire expression, dp dt equals 0.4p minus 0.001, sorry, it's a point here, 0.001p squared. And in the last part we found that carrying capacity m is equal to 400. We were also given that p0 is equal to 50. So we are asked the question, what is p prime of 0, or the rate of change when population is at t equals 0. So we know that because of this value, P as when population at time equals 0 is equal to 50, we can plug this right into our rate of change equation, dp dt. So let's do that. We have 0.4 times 50 minus 0.001 50 squared. So now if we just plug that into our calculator, 0.4 times 50 minus 0.001 times 50 squared, that gets us 17.5. So p prime of 0 is equal to 17.5. So this is part C of number 9 on the integral quiz. We were asked when will the population reach 50% of the carrying capacity? Given everything we've already done for this problem, we can use the general equation given by P equals m over 1 plus b e to the power of negative mkt to be able to find out exactly what b is. So this is just some constant that affects the rate of growth. So if we set p equal to 50, because this will make time 0, we can set it up like this, where it's 400 over 1 plus b, and then because of that 0 as t, we can get b all alone, because e will simply equal 1. So next up here is to distribute, so we end up with 50 plus 50b is equal to 400. Then subtract, so we can cancel out this, but minus 50 is 350. So we have 350 is equal to 50b. Divide each side. So this a equals 7. B. Let's put that to the side. And I'll be right back. So this is part 2 to problem C, 9C. So we're given all these expressions. We're given population as a rate. We used the general expression p equals m over 1 plus b e to the power of negative mkt. We just found the constant b. So now we need to find the constant k. Just look at the exponent. So to find this, we're going to use another general equation. We're trying to get this entire expression up top to be the same as the general expression k p outside of m minus p. And that's p as population, k as a constant, m as in the carrying capacity. So what you'll notice with our population growth equation above is that it's very similar to this general equation. So what I'm going to do is I'm going to divide both sides, the entire expression, by 0.001. So by doing so, we end up with 400 p minus p squared. So we can take it under the p, take it under the p, erase this, just rewrite this. This matches our original equation. So now we can see that our constant k is right here. K is equal to 0.001. Let's write this right here. K is equal to 0.001. I'll be right back. So this is the final part to problem 9c on the integral quiz. So again, we are trying to find when will the population reach 50% of the carrying capacity. 50%, which is also known as half of the carrying capacity, would be 200 because our carrying capacity is 400. So I've written this up here. So now it's time to solve for t. So the first thing that we need to do, distribute. You're getting 200 plus 200 times 7, which is 1400, e to the power of negative 400 times 0.001, which I'm actually going to simplify that to negative 0.4 t. That's equal to 400. Sorry. Alright. So, next thing we can do, we can subtract. So, get rid of these. So now we have 200 is equal to this 1400 value. 200. And then we're going to divide. So 200 divided by 1400, the same as saying 1/7. So 1 over 7 is equal to e to the power of negative 0.4 t. And what we can do here is we can use a natural log on each side. So we end up with this expression being ln of 1 over 7 is equal to 0.4 t, and then divide. 0.4. And so when you do this value out in a calculator, you end up getting a really small number. You end up getting, just punch this in my calculator. You end up getting 0.77836, and that is our answer for C. So this is the integral quiz, problem 10. We are told that a population has an initial population, so P0 is equal to 1,000. We're told that the carrying capacity is equal to 10,000. And if the population grows to 25,000 after 1 year, so when P1 is equal to 2,500, what will the population be after 3 years? So the first step in this entire escapade is going to be using our general equation, P equals m over 1 plus b e to the power of negative m kt. So we're going to have to plug everything in. So since we know that P0 is equal to 1,000, and because 0 takes out the e from the equation, we can solve for b that way. So we'll go 1,000 is equal to 10,000 all over 1 plus b. So distribute 1,000 plus 1,000 b equal to 10,000. Now divide. We end up with 10 and 1 plus b, and then subtract. B equals 9. So let's write that over here. B is equal to 9. Let's erase this. Alright. So now we need to find out what our constant t is. So now we have an example. We have the P1 is equal to 2500. So we can use this equation actually. So when population is equal to 2500, we have 10,000 all over 1 plus 9e to the power of negative 10,000 k, because time, which is at this point 1, is multiplied against any constant. It's going to be that constant. So we're going to go the normal steps. Distribution, 2500 plus 9 times 2500, which is 22,500 e to the power of negative 10 e to the power of negative 10,000 k. So now all equals 10,000. Can't really fit that, so I'm just going to assume it. So next step is to subtract, then divide. So actually, let's divide first. So let's make things a little bit nicer. Let's divide by 2500. End up with 4 equals 1 plus 9e. And this nice stuff. And then subtract. So you end up with 3. Then divide. Divide by 9. And then end up setting this equal to e to the power of negative 10,000 k. So we can do natural log. So natural log of 1/3, simplification of 3/9. And we can also divide by negative 10,000 equal to k. So let me clear some space. So now we know that k is equal to, if we plug this into our calculator, we end up getting a really small number, but actually I'm not going to use the calculator for that, so we're just going to leave that there. So now if we plug everything that we have, so we have 10,000 for 1 plus 9e to the power of negative 10,000 k, then times 3, because we're looking for 3 years after. We can end up getting, after all of that, we're getting population up to 3 years is equal to 7,500. So that is our answer for 10. Thank you. This has been all of the integral quiz. Have a nice day.